As we continue in Chapter 2, Section 2, we're having another snow day, sort of. So, again, if students watch this, take the notes on it, and they can use their little booklet, show me the notes. That will be the makeup if you miss the class. Otherwise, you can watch it as enrichment, and I suggest that too. Linear functions. Linear functions are designated by the formula f of x, which is your function notation, equals mx plus b. And you recall that m is the slope and b is your y-intercept. This would be in slope-intercept form. I should write it there. So I have here a 2 and a 2a. The reason being that here is the traditional y equals mx plus b is the slope-intercept form. And then when you replace the function notation with the letter y, or y is replaced with the function notation, it then puts it in a linear function, so to speak. Now, one of the things we talked about in our class today was graphing slope-intercept equations using a special technique. And that technique was to find out what the y-intercept was, which is what the b is, and then finding out what the slope is. And then using that information to graph. So here for number 5, they give us the function of x is that negative 2x plus 3. So we can compare this to number 2. It's a form of the same slope-intercept form. But now we're going to use the technique of graphing the y-intercept first. That is where that will cross the y-axis. It's going to cross the y-axis at 3. So 1, 2, 3, we put a dot right there. And then we're looking at our slope, which is negative 2. But remember, a whole number is always over 1. So in a sense, the ratio of y units to x units, which we'll get into a little bit here shortly, which we already covered in our class. Slope is ratio of y to x, rise to run, and if we have two ordered pairs, we use that formula, which we'll use a little later, but now they're asking us to graph. So we put a dot at 3. Now this is negative. Now we could put the negative down here if we'd like. That's the way I like to do it. So our run is horizontal, be 1 unit to the left, and then our rise up is 2 units. So we've made 2 points, and these we don't usually write. I'm putting them there to show you. But you would put a click on that, fix that point, and then go over 1, up 2, and then draw your other point like so. And that is the technique we're featuring in this section, where we graph this linear function, which is in slope-intercept form. For example 6, again, we have linear functions. They want us to graph it. So in your homework log, you're sketching, you plot your y-intercept first, which is -1. Your slope, which is 2/3. So I'm going to do my run, which is positive. So I go 3, up 2, and there's my line. I was off a little bit. You have to be careful. Use a straight edge, your ID card or something. Now here, something very simple. It says determine the y-intercept. So here, this equation is in slope-intercept form. Equation number 2. So whatever is in this position is your y-intercept. So we could say b equals 5, or the official way to write it is 0, 5. This is the official way, and this is an acceptable way. Now notice this is in function notation, but it's a sister or brother of our slope-intercept form. Remember, we can always substitute a y here. So our y-intercept is 0, -17. All right, for 9 and 10, they want you to find the slope. And for that, we'll use this formula. And I've memorized it. You're going to have to work out a way to do it. The way I do it is I take this last point, that's my y sub 2, minus y sub 1, x sub 2, minus, now this is where it's tricky. Minus is in the formula, and the actual term is a -2. So put that in a parenthesis. Or, when you're writing it, if you see it's the opposite of a negative, right away you can make that a positive, like so. When you have two negatives like that, you can do that. So this is going to become 6. 6 minus 3 is 3. And then 1 plus 2 is 3. So here the slope is 1. And remember, that's in a sense 1 over 1. But don't put this here. We're just going to use that when we're graphing. All right, same thing. Y sub 2, -1, minus a -1 makes this a +1. And this is a -5. Minus a -2 makes that a +2. And this becomes 0 over a -3. Well, we had said that from chapter 1, 0 divided by any number other than 0 is 0. So here, the slope for that one is 0. All right, examples 11 and 12 are fractions. I'm going to skip those. You can do them if you like. 13 and 14, they want us to find the y-intercept and the slope and then graph it. So for this one, the slope is a positive 3/2 and the y-intercept is a -5. So I'm going to go down here to -5, 2, 3, 4, 5. There's my dot. My run is 2, and it's positive. And my rise is 3. So my graph is something like that. And you go through that point too. Now for number 14, here this is in standard form. So if we want to easily find the slope and the y-intercept, we have to solve this equation for y, a positive y. So I'm going to transpose the y to this side to make it positive. Transpose the 4 to this side. That'll then make it negative. And then I can rewrite it if I'd like. Y equals 3x minus 4. So now I know my y-intercept is a negative 4, and my slope is 3 over 1. So, make my little graph. My y-intercept is negative 4. 1, 2, 3, 4. Put a dot there. My run is a 1. It's positive. And my rise is 3. And then there's my graph. Again, if you want to see these again, just rewind the tape, and you want to try to do it so that you end up with this results. Okay, going on to number 15 now, we see it's in standard form, and whenever it's in standard form, we need to solve for y. So I'm going to transpose the 4x, and my 6 stays there. And now I'm going to divide each term by 3. And I get y equals a negative 4/3 x plus 2. So this is a trait that you should have picked up in chapter 1 when we were solving for various letters, but we're using it and you're reviewing. And now to graph it, put a dot on 2, the y-intercept. The slope now is a negative 4/3, so we're going to go over 3 to the left and then up 4, and then there's our graph for that. Now for number 16, remember this was a modified form, which was f of x is equal to mx. There is no b term out here. Whenever there's no b term, the origin is the y-intercept. So there's our graph. B is the origin. There isn't one. And then our slope is a negative 3/4. 1, 2, 3, 4. To the left, 3 up. 1, 2, 3. And there's our graph. And a little hint, I didn't go over this yet, but we did it in class, that any time you look at a graph and it starts low on the left and goes up, that's positive slope. Whenever it starts high on the left and goes down as it goes to the right, that's negative slope. So here, this is negative slope, and it's going down. This is negative slope, and it's going down. Okay? And then again, your y-intercepts indicate where it will cross the y-axis. All right, I've shortened these a little. Slope and y-intercept for each one. They want us to write an equation in slope-intercept form. So it looks like this. Y equals, there's my slope. Now you have to add an x, and then your y-intercept. Here, y equals your slope, add an x, and then the y-intercept. Slope, add the x, and your y-intercept. Slope, add the x, and your y-intercept. So again, if you know your slope and your y-intercept, it's easy to write an equation. And you'll be doing some practice on your quiz piece. Well, I only have up to 20. There are more examples, but I didn't include them here. I don't want this to be too long. But one thing that I want to go over with you if you see an equation that's represented by this graph, and they said, look at the graph and write an equation, you might say, how do I do that? Well, of course, on your graph, they would have some marks here. And looking at this, you see, first of all, what is your y-intercept? Well, it's this point right here. So that would be 0, 4. And this happens to be your x-intercept, which is -3, 0. Remember, this is 0, b, and this is a, 0. Well, we know that if we know the y-intercept and we know the slope, we can write an equation for this line. So what we have to figure out now is the slope. And we said slope is y over x units. So what is our y units? How many y units do we go up? Well, we're going up 4. How many units are we doing in our run? 3. So our slope for this particular graph is 4/3. So we now know the slope that we've taken right from the graph as a ratio of y units over x units, y over x. And we also know it's positive, because it's going up. That our equation then is going to be y equals 4/3, we have to add the x, plus 4. There's the equation of this particular graph. Now, we didn't have that as a question, but I thought we mentioned this in class a little bit, so I wanted to illustrate it here. Okay, this will wind up our lesson for today.